The sine and cosine ratios. Previously, we had looked at the tangent ratio, and the tangent ratio was used to build a relationship between the acute angle measurements within a right triangle and two of the sides that we have, which we had called the opposite and the adjacent. The opposite and the adjacent were described with respect to where the chosen acute angle measure would be in the picture. For example, in the one that we're going to see here, the 47 degrees, if we let that be our focus, we call that our theta, then the opposite of that is going to be the E, that's completely across the figure, and the adjacent would be next to it. But when we looked at the tangent ratio, we didn't really do anything with the hypotenuse because, well, a ratio can only involve two numbers at a time. So what we're going to look at now, the sine and cosine ratios are going to bring the hypotenuse in. Because if we have the hypotenuse, we should be allowed to use that to solve for another side length. Or if we have a certain side length, we should be allowed to use that to solve for the hypotenuse. So bringing the hypotenuse in, if we associate the hypotenuse with the opposite side, we can build a ratio there, and that one we're going to refer to as the sine. So the sine of any angle, and by the way, do not read that as sin, okay? It is sine. We abbreviate it as SIN, but it is still read as sine. So if we were to take the sine of an angle, it is going to be equivalent to the ratio that we would get from the opposite side of that angle and the hypotenuse. All right, so for example, number one, what we're going to look at is a right triangle. And again, it does have to be a right triangle. Everything that we're doing currently is about right triangles. Okay, so we have a right triangle with an angle measurement of 47 degrees. We should go ahead and just let that be theta. However, I will go ahead and mention right now that you can technically use this as your theta if you want. You would just need to use the triangle sum to figure out what that angle would be. In this case, it would be 43. But usually, I think it's easier just to go with the angle that's actually provided in the picture. So we could use the 47. Okay, now with respect to the 47, E is the opposite side. This is the hypotenuse that we have here. Okay, so we have the opposite side here. We have the hypotenuse here. This would be the adjacent side. Okay, now the adjacent, we don't know what it is, and we're not really interested in figuring out what it is. We aren't. Okay, so we'd want to look at these two, which is the hypotenuse and the opposite, not the adjacent. Okay, so tangent would have used the opposite and the adjacent, but what we're going to do is use the sine because of the items that we want and what we have. Okay, so we'll say that the sine of 47 degrees is going to be equal to the opposite side, which in this case is E, divided by the hypotenuse, which is 19. Okay, and then to solve for this, because your variable is on the top, what we'll do is multiply both of the sides by that 19, cancels here, and E is going to be equal to 19 times sine 47. All right, so let's see what that will look like. We'll take 19, multiply that by the sine of 47, which in a calculator like this, you can just type the numbers like back to back with the sign. And that's it. E, let's go ahead and round it to, I guess 1 decimal would be fine because that 5 would actually bring it up to a 90. So we just write it as 13.9. Okay, and let me officially state it this way, that it's E, that would be equal to 13.9. We do have units, which are meters, so I'll go ahead and add that in. And that's it. All right, next what we're going to do is look at the cosine ratio, which is going to be abbreviated as COS. Okay, please do not read that as cos. This is the cosine that we're looking at. Now, what the cosine is going to do is relate the adjacent side to the hypotenuse. So at this point, we will now have a relationship between any two sides of the triangle. Okay, when we did tangent, it was the opposite and the adjacent. When we did the sine, it was the opposite and the hypotenuse. So then our last combination is going to be the adjacent and the hypotenuse, and that will be our cosine. All right, so for our problem here, we're going to be asked to solve for D, okay, and with respect to the angle that we see, the 24 degrees, D is the hypotenuse. It's the hypotenuse. It would be across from that right angle. The 15 is going to be our adjacent. Okay, now remember that The hypotenuse is technically adjacent to that as well, except for the sake of not making things confusing. What we do is identify that side length as the hypotenuse, which is across from the right angle, and that's already a name that we know. So we'll just keep with it. The third side here that we don't really need, you're not asked for it, and you're not provided that number, that would be the opposite. So sometimes it's good to label everything because there's always that chance that you could get things labeled incorrectly, and once you get to that third one, you'll figure out that, oh, that's not actually the adjacent. It's the opposite. You'll figure those things out. So I think it's a good idea to label all of them. However, once I do have them labeled, what I might do is just cross out the one that I don't really need. But I feel confident that I've got everything organized. All right, so we are going to be using the adjacent to find the hypotenuse. Okay, and that's what cosine can be used for. So the cosine of our angle, which is going to be the 24, we'll set that equal to the adjacent side, which is 15, divided by our hypotenuse, which is the d. All right, so this is that different case where your variable is in the denominator. And you can solve this by two steps. First, you can multiply both sides by d. You can do that and it'll cancel here. The d shows up over here, but then you would have to divide by cosine 24 to get the d by itself. In the tangent video, I did offer a shortcut to this, which is ultimately the same work, just getting there faster. What you can do is switch these two things around. You can rewrite the equation as d equals 15 over cosine 24. Okay, the same two steps would get you to that place. It's just a little bit faster. Just go ahead and switch those around. All right, so let's go ahead and evaluate this. We're going to take 15 divided by cosine 24, which is going to give us 16 point, let's call it 16.4. Okay, so d is going to be equal to 16.4. All right, for example 3, what I want to do is show you that you have a little bit of freedom in how you approach problems. Okay, so we're going to do the exact same problem as example 2, which means that the answer is 16.4. That doesn't change. Everything about this is the same triangle. The answer will be 16.4. However, what I want to do here is solve it not by using cosine, but by sine. I want to use that one instead. So the way that the problem is set up, it's perfect for cosine, and you should probably go that route. That should be the way that you do the problem. But the difference between the sine ratio and the cosine ratio is just whether or not you use an opposite or adjacent side. That would go with it. Now, if I attempt to use this angle, 24 degrees, and sine, that doesn't really make sense because I don't have the opposite side. I can't do that. I can't do that. I don't know that side, I can't use it. I've got to be able to use the 15. However, a triangle is going to add up to 180 degrees. And this being a right angle, if you take that out, it tells us that these two angles are going to be complements. So if I were to take 90 degrees, which is these two together, and subtract 24, that is going to give me 66. It's going to give me 66 degrees there. All right, so this right here would be 66 degrees. Okay, so I could use that angle, and with respect to that angle, the 15 is the opposite. The adjacent would be here, which we're not going to use. D is still the hypotenuse. Still do that. So I can set up a different problem. I could write that the sine of 66 degrees is going to be equal to the opposite over the hypotenuse, which is D in this one. And again, I can use that little trick. I could rewrite this as D equals 15 divided by the sine of 66. All right, so let's see that one. If I take 15 divided by the sine of 66. Okay, so I'm changing the sign. I'm also changing the angle to the complement of the angle that we would have been using before, the 24. And you get exactly the same answer. You still get 16.41. Well, in the other one, I rounded it at 4, so I'll just box it that way. Units, we got meters. I don't think that I wrote the units last time, but they are in meters. There they are.
Wait, what?